Hey everyone, it's Justin again, and I am very excited to learn about linear inequalities with you today. Now, before we get started, I have a task for you. There's an activity in your PDF called Graphing Review. It's super important that you work through that activity before continuing with this lesson to make sure you're prepared for what's to come. So pause the video now and come back when you're ready. I'll see you soon. How'd the graphing activity go? Did you check your work by viewing the key within adults or using the video link at the bottom of the page? If you didn't, do that now. Okay, now you're ready to take these graphs to the next level using inequalities.
Let's start by graphing something we're familiar with. For an equation like this, where are all of the solutions shown on the graph? Yeah, they're all the points on the line. We can substitute any points on this line into the equation to see that they make the equation true, like the point 0, 3, or the point 6, 5. But what if this equal sign is an inequality instead, like a greater than sign? Would these points still be solutions? No, substituting in those same x and y values no longer gives us true statements. 3 is not greater than 3, and 5 is not greater than 5. So if points on the line aren't solutions to this inequality, then how do we show people that? We actually need to make this line dashed rather than solid. Now, if the points on the line aren't solutions, then where are the solutions? Well, they will either be all of the points above the line or all of the points below the line. This is exactly what I'm going to teach you about next. And now that we've decided between a solid and dashed line, depending on whether the solutions include points on the line or not, I could teach you about the shading so we can show where all the solutions actually are. Let's move this over a little so I can teach you about this other important part of graphing inequalities, shading. If we shade above this line, that would mean that all the points above the line make the inequality true. If we shade below the line, that would mean that all the points below the line make the inequality true. So how do you think we can decide where all the solutions are? Well, since this is an inequality, this means that our solutions are either less than or greater than something. So we need to substitute a point either above or below the line into the inequality to see if it gives us a true statement. We'll call this testing a point. If we test a point above the line and it gives us a true statement, then all the points above the line will also be solutions. The same is true about testing a point below the line. If one point below the line gives a true inequality, then they all will. There are really infinitely many options for points we can test, but let me narrow it down to just a few so you can decide from there. Out of these points, which do you think would be the best point to test? Well, the point 2, 4 is so close to the line that it's difficult to tell whether it's above or below it. Even worse, what if it's on the line? We already know points on this line are not included in the solution. We should choose a point far enough away from the line that it's clear whether or not it's above or below the line. So out of these 2 points, which should we test? Negative 2.5, positive 6.3 is definitely above the line, and 0, 0 is definitely below the line. So either would be great, but which would be the easiest to substitute into the inequality? I really don't want to substitute in decimals. It would be easier to make mistakes when doing my calculations. Anything with integers would be better, like 0, 0. Go ahead and substitute 0 for x and 0 for y into the inequality. See if you get a true statement or a false statement. Since this point below the line gave us a false statement, and is not included in the solution, what do you think would happen if we tested any other point below the line? Yeah, they would also give us false statements and would also not be in the solution. So where do you think the solutions are? They have to be above the line. If we tested any points above the line, they would give us a true statement, like this, for example. Substituting this point gives us a true statement. Or this. This point also gives us a true statement. Since points above the line give a true statement, and points below the line give a false statement, we can confidently shade this section in to show that all the solutions to this inequality are above the line, not including the points on the line, since our line is dashed. Great job here. Now, what about if we use the other inequality symbols? How would we graph those? Well, we need to keep these same two things in mind, whether to include points using a solid line or not, and which part to shade to show the rest of the solutions. Go ahead and see if you can represent the solutions for each of these on a graph. You already know how to graph this line if it were just a regular equation, but try it now with these inequalities. Let's talk about solid versus dashed lines first. When we have an equal sign, points on the line create a true statement. Do you see which of these still contains that equal to condition and would still use a solid line? Yeah, the inequalities greater than or equal to and the less than or equal to will always use a solid line to show that points on the line are solutions. The inequality less than will use a dashed line because just like we discovered with the inequality greater than earlier, points on this line will not make a true statement when substituted into the inequality. Now we need to figure out where the rest of our solutions are so we know where else to shade. If you haven't already, choose a point on each of these three remaining graphs to test. If it's true, you'll shade the section that contains that point, and if it's false, you'll shade the other section. Pause the video now and take all the time you need to get comfortable with this process. Let's check your shading on this one. I was planning to test the point 0, 0 here since I could clearly tell which side of the line it's on, but my friend Jenna insisted that I try something else just for fun. She chose the point 3, 1. We substituted 3 for x and 1 for y and ended up with a true statement. Since it was true, we can say that all the points below the line, like 3, 1, are solutions. Now, if you made a mistake and ended up with the wrong shading, check to make sure that whatever point you used, you correctly substituted the x value in for x and the y value in for y. Then double check your calculations when you simplified. Now, for these last two, I really did just substitute in 0, 0, and that gave me 0 is greater than or equal to 3 for this one on the left. Since that's false, I did not shade in below the line where 0, 0 is included, but rather I shaded in the other half of the graph above the line. When I tested the point 0, 0 on this last one, I got that 0 is less than or equal to 3, which is true. So let's make sure 0, 0 is included in the shaded section. This means I get to shade in below the line. Now that you've seen every combination of dashed and solid lines and shading above or below, remember what each of these means. Points on these dashed lines are not solutions to their inequalities, but points on the solid lines are solutions. And points above these lines are included in the solutions, while points below these lines are included in their solutions.
So, how are you feeling about those two extra graphing steps when it comes to graphing inequalities? There's a summary page in your notes template to fill out that can help you organize your thoughts. Take a few moments now to fill in that summary sheet. All right, it's time to go back to those graphs you made at the beginning of the lesson. You're going to work with those exact same problems, but this time their equal signs have been changed to inequalities. Your job is to graph their solutions and answer a few questions. You'll find this in the activity in your PDF called Inequality Graphing. Work through that next so you can be sure you're ready for the practice game. Good luck with that, and I'll see you next time.